Hey everybody, I think everything is working. You probably can only see Infinite Mirror at this point. There we go. There's a couple people coming in. Hi everybody. So today we're going to be doing some programming, which I know is probably a great stream, maybe not the best content in the world. But this is like there's not a lot of this information out there, and so I figured I would do some of this stuff live so that I could share some of this information. These are the Tormach probing macros, and I am doing some edits on them so that they have the ability to do in-process inspection. So that's what I'm trying to add. This right here is the one I'm working on. This is the Boss 3-point probe. I'm almost done with all of them, but I just have this last little bit to do. Hi, Jacob. So there's some corrections we need to make here. I had ChatGPT do some math on this one for me, and some of the formatting is wrong. So, hi, Kelly. This is information you've been looking for. And yes, this is the first part of Automation Week. I've actually been slowly working on this in the background, but I set aside like 2 hours to work on this today and like an hour to work on it yesterday. But this is part of being able to, make things reliably. So maybe this is not the best one to start showing off because this is one that I need to work on. Where's one that I've already done? Or at least done some of it. So here, like XBoss, we'll do that one. So this will probe. So like if you have a feature that looks like this, it'll come in and probe this side and then come in and probe that side. So starting off here, and this is what Tormach wrote. I didn't do this part, but they have some debug code here. Then they figure out where they are currently. And then it looks like it looks like they basically go straight to probing. So they must start on one side of it. The post processor gets some say in this because it gets to choose the initial position. And so they must know that they're starting on like the left side or whatever, because the post processor determines that. So they start off by doing a G38. That is just a probe move. And this is the fast boop. They do a quick boop with the probe rough feed rate. Then it looks like they do some math to figure out if they are on the left or the right side of the part. And then they retract. And then they do the slow probe boop. Save that. They do another retract. Then they go up to the clearance position, travel over to the other side. Fast boop, retract, slow boop, retract. And then down here, it looks like that's still the retract. And then down here, they do some math to find the center of that boss, and then they set that as the probe position. So what I'm adding is basically all in this here. For the most part, I don't have to mess with Tormach's macros at all. I do in a couple places to make the math a little bit easier to follow, but for the most part, their stuff is just kind of perfect right off the bat. The Tormach macros are so much better than the Renishaw macros. The Renishaw macros are impossible to follow because like every single line of code is another macro. And to figure out anything, you have to go like 12 macros deep. Whereas with Tormach, it's all here kind of on this top level. So, and they're also very consistent between macros. So most of the time I can kind of copy paste most of my code and just tweak a couple things. But then this little function I have here. So the first thing it does is it checks if a global parameter called print results equals 1. If it doesn't equals 1, then it won't print anything. It's not doing in-process inspection. It's just setting the work coordinate system. If print results does equal 1, which we're going to have the post set. Right now, the post doesn't do this. Then it will go ahead and it will print this. This is the Fusion readable format for generating inspection reports. So it'll spit this out into a text document. that you'll be able to put back into Fusion and get a visual graphical visualization of where the errors are on your part or in your whole set of parts. If we go back to the top here, so the first thing it does is it determines what feature it is. Basically, this needs to be added to the post processor, but the post processor at the beginning of the program will add this feature number to 0, and then it's just a counter. So feature number equals to feature number plus 1. So every time you probe something, it bumps that up 1. Component number, this is based off of the component counter built into Fusion. This is something that you will have to manually reset, which Norman gave me the code for, but I don't remember what it is off the top of my head. But we could also do something like, really all we need to do is, number 5389 equals 0, and then that should reset that counter for you. After that, we do some math to figure out the size of the boss in this case. So it figures out the Norman is the guy who works for Tormach that I know the best. He works in their support department. I believe he wrote these macros. He was in the 1500 video. He's not their CEO, which I think I talked to in some of the videos. But he is I don't know. He's not in charge of support, I don't think. Maybe he is. I don't know. I think the organization's a little bit looser than this is the support manager, but he's one of the more technical people at Tormach, and so he's kind of the person I talk to the most. G10 L99P0 Q0 is the change the counter. Yeah, I think that's what Norman gave me. I don't see why you can't just set parameter 5389 to whatever you want, though. It's a lot less words. Kelly, do I have a recommendation on probes, live or passive, Tormach brand or ITTP? I assume you're not talking 1500, because the 1500 has the wireless probe from someone. I don't remember who makes the Tormach wireless probe. Is fine. I haven't had any issues with it. I was worried about it at first, but I've had no issues. If you're going wireless, I would find a used if you're going wireless on the not 1500, or if you're trying to save a buck on the 1500, I would buy a used Renishaw, honestly, because the same macros and everything will work. You'll just have to figure out how to wire it in yourself, and that shouldn't be that big of a deal. It's just a skip signal. If you are getting a wired one, just go with the Tormach one. I tried the Drutronics wireless one that you retrofitted in, and I had nothing but problems with it. The Drutronics wired one was fine, but their wireless one, I just never got working. I've heard good things about the ITTP. I've heard good things about those, but the Tormach probe is fine. I wouldn't bother going with anything else personally, unless you want wireless. In that case, I would go with a used Renishaw system, or just, buy the one from Tormach. Silver CNC, thank you. Yeah, you can't find other TTS probes, but you can get probes with an 8mm shank and just stick it in the same TTS holder that the Tormach probes use. That's not really a big deal. When are you getting the chip conveyor? When I have money. And it integrates directly into the software. There is already a button that just turns on the chip conveyor. And I know they have some Gcode options where you can tell it to run for 10 minutes out of an hour, or run for 10 seconds out of a minute. I don't remember how that works. There's a bunch of Gcode commands, but there's also just a soft button on the screen that's chip conveyor. Which, fun fact, I'm going to be using to run some of my automation stuff, because there's 2 inputs and outputs that I'm not using at the moment that are available without me buying the USB I/O board, and that is the TSC output and the chip conveyor output. Both of those are 24-volt signals that I can use straight from the controller, no modifications or anything needed. And as a bonus, there's a soft button on the screen. So one of those can be an auto door, and the other one can be the Vice or Vice and Air Blast or whatever. But those buttons are already right there on screen. So that's what I'm planning on doing for that. It would be nice if Tormach sent me the chip conveyor. Maybe if all of you guys buy 1500s, then they'll sell me one. Yeah, Zoom Speed has one, but if I remember right, it's not that much cheaper. And I don't know, the Tormach one's supported by Tormach, but I mean, yeah, the Zoom Speed guy has a bunch of cool stuff. If you want to go something that's a little bit more DIY, and if it's cheaper, then go for it. All right. Anyway, back to our macros here. So the component number just comes from the counter, which you can reset via that long string of Gcode that Jacob gave us. And so this way, if we look down here at our results that we're printing, that's this component number right here. And Fusion will know that that's a new iteration of a part. And then you have the feature number, which Fusion will be able to say, okay, this boss in your CAD, that's going to be feature number 1. That boss in your CAD is going to be feature number 2. This hole is going to be feature number 3, etc. So the feature numbers are going to reset with every program. The component numbers are just going to keep counting up until you reset them. The expected size is based off of the probing positions. It basically is just finding the difference. The actual size is based on the results of the probing positions. And then the error is, of course, just the difference. And then they already calculated the center. We just had to calculate the expected center here. And again, we can do the error. Since this macro is only doing the x-axis, the format for the Fusion readable document is to have it marked as not a number. So for the y location, we're just not a numbering everything. Now, I did realize I don't have a z location on here, and I'll need to check to see if Fusion is expecting that. So there's a possibility we just have to copy paste this and change everywhere it says Y to Z, but that'll be pretty quick if we need to do that. Secondary Modbus is so easy, no one should feel pigeonholed into one system. Please explain. I know vaguely what Modbus is. But I don't know how you would integrate that to PathPilot. So if you know that, I would be curious. But okay, so this is one of our finished macros here, or at least for the most part. I have a couple things on my to-do list. First and foremost, right now, if you do this inspection routine, it will change your work coordinate system, which is not always desirable. So we need to add one more logic step here to where it doesn't actually change the work coordinate system. But I haven't gotten that far yet. I'm going to, excuse me. I think that code will be the same in all of the macros. So I'm just going to finish what I'm doing. Oh, that one. That's the where. I'm just going to finish what I'm doing and then figure out that code later and just copy paste it in. There's probably a better way of doing it, but what I'm going to do is just save the current WCS to a variable right at the beginning of the probing macro. And then at the end, if the user says they don't want to change the work coordinate system, it's just going to shift it back to whatever the original value was. That's probably less desirable because it's doing all that math in there for nothing. But I think there's not an easier way to do it without rewriting the entire macros, which one, I just don't have the skill to do, and 2, it sounds tedious and annoying. So, but all right, so we need to go back to this one here. So this is the one that I was working on. This section here, ChatGPT did the math for me, which in retrospect is actually pretty obvious. This is... Yeah, I don't know if this is actually right now that I look at it. Because it's just going off the X center, not the X and Y center. Darn ChatGPT. Yeah, this doesn't work, does it? Because this... that right there, a squared plus b squared, we're doing some Pythagoras here. but we need both the X and Y components. So that doesn't work. Okay. This is why you can't trust ChatGPT. Oh, no, sorry, I wasn't scrolled down. So Modbus is general communications terms for anything from 232 to IP. Interesting. It's a big part of what industrial control was built on. They might actually even have that because they have all their robot stuff. Okay, so we need to figure out how to do this math here. So I think... Oh, wait. No, it has their Y centers here. Okay. Hold on. Maybe this is right. Now, they do... The format here is wrong because that format doesn't work in Gcode. This needs to be the exponential function, or I may just break it down into multiplication. But okay. The square root of x minus first vector x squared. Okay. Plus the square root. So that's... Oh, I don't know. I don't know if that math is right. I might have to draw it out. The square root of... Okay, wait, no. Okay, so so this section squared plus that section squared. So we're looking for... So a squared plus b squared equals c squared. If we want to get c, we take the square root of a plus b. This would be a, this would be b. Okay, so that math is right. The only problem is we need to figure out this exponential because that is not the right format, I don't believe, for Gcode. Now, annoyingly, I have been trying to figure out the proper format. This is what the Tormach website gives you, but this isn't complete because it says exponential of argument e raised to given power ex. Like, I don't know what that means at all. Is it supposed to be like exp open bracket the thing you want to raise comma e, or what? There's not enough arguments here in this sample they give. I tried the Linux CNC page too. Do I have that here? No. The Linux CNC page gives exactly the same thing, and I have not been able to find a single example of what this should look like in any code anywhere. So what I'm going to do instead is I think I can just take this. This is going to get really messy here. And I'm going to do a multiplication of that. So basically, that thing times itself is the same as squaring it. And if I do that here, if any of you guys know the proper format for the exponent, that would be fantastic. Let's continue doing that. Well, maybe I should just copy paste the first line and then change first, second, third. Okay, so second, third. Oh, we can copy paste now. Aha. Second, 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 third, third, third. Okay. So now we should have our math right for the radius. Let me put some spaces in here to make it a little bit more readable. Spaces don't matter in Gcode. You can use them arbitrarily. Let's make it all lined up. Okay. Does the E format not work? I just don't understand what it wants from me. Hey, man, how's it going? we're doing some Mcode program or some macro programming, trying to get the Tormach probing macros to do in-process inspection. So right now we're fixing some formatting issues that ChatGPT spat out for us, but that should be good. Okay, so it calculates the radius to all 3 different points, and then it multiplies them by 2 to give us the diameter of each of the 3 points, and then it averages them. And then I don't know why we're averaging the radius. That doesn't make sense. We don't need that. Oh, it uses it in the error. Never mind. So it averages the 3 radiuses, and then okay, we don't actually need this math up here because it's giving us the 3 diameters based on the 3 different radiuses, and then it calculates the average diameter based off of the average radius. So this actually isn't being used at all. So we can get rid of that. So this macro is the 3-point probing macro. So if you had like a circle, it would program or probe like top, bottom right, bottom left, and then do the math to figure out where the circle is from there. And your circle could be out of round. And if your circle is out of round, these 3, like the 3 different radiuses could be different. And so it's just averaging them to find the average size. That's what that's doing. And then it calculates basically the run out on your circle. This isn't being used anywhere, but I figured it would be good to have for future usages. Maybe Fusion adds it down here, or potentially you could add some logic to like pause if it has 10 thou of run out or something like that. But let's see, that should be good. It calculates the error. So we figure out the expected size. This is some nonsense coming from the post. Don't worry about that. The actual size we measured is the average diameter. The error is the expected minus the actual. So I realized I made a mistake on a couple of the macros, and I need to redo the expected X and the expected Y. But once we have those, we already know the X center that was calculated above. And then the error is, again, expected minus actual. And then it prints it. So I just need to go figure out the expected. What is my criteria for part inspection based on? Part count, I assume it'll change depending on tools and material. So with this in-process inspection, I think it would run every part, and at least on some features. And you can't really use the in-process inspection like on a formal inspection report that you send to your customer, but you can use it to track like the stability of your process, and like you can use it to identify if there's any like weirdo, like, one thing is wrong on this part. So I like it'll identify outliers. That's what I'm trying to say. This will help you identify outliers, and that'll kind of help you, like if you're running 100 parts, I might do a sample of 10 of those 100 parts that I'm measuring myself all the way through. But if I can go back and on a list and say, okay, part number 27, something's really weird about part number 27, I should go test, or I should go manually inspect part number 27 to make sure it's good. So you can't really use this to send to a customer, but you can use it to help kind of dial in your process and make sure that there's nothing weird slipping through the gaps. Xometry has requirements for what is inspected on how many parts. Do they actually? It's in my like quality plan, but I don't know if Xometry has any written requirements for that. I generally do spot checks on every single part, but generally like how many I'm doing 100% inspection on is determined by my inspection plan. But if Xometry has rules, I would actually be interested in knowing that, because I don't think they had those when I first joined. All right, so we need to figure out the expected X and Y location. Which let's go look at this macro, because I think I think we might be able to use the X and Y here because I think it'll come down over center of where it thinks the part should be. So if we open up Fusion, so I this is my like plate work template. I just added a feature to. So let's change this to the 3-point boss there. Okay. And yeah, if we look at this, so it's coming over where it thinks is center. Now, it might not be center because that's why it's probing in, but it's going to come down where it thinks is center. And we can even post this and look at the code. So here, these are the diameter probe and the diameter 2 position. That's where I'm getting what Fusion thinks is the size. Jacob, you DM'd me a sheet and link on Discord. Thank you. I appreciate that, man. So let's see. First, second, third vector, those are the angles that the X and Y WCS offset, that is the distance from the object we're probing to wherever the work coordinate system is set. So yeah, and it's not passing any other sort of position. Okay, so wherever it's centering itself, that is where it thinks the center of the feature is. So that's what we get to use to figure out our where to go. So those two right there are our X and Y position. And those shouldn't change. The 5420 and the 5421, those will change, but it's saving it into 1 and 2 here, and those shouldn't change. So if we come down here, X was that 5420? And Y was 5421. So those numbered parameters, that's just coming straight off of the controller. And that is like, this is just your current location. Like 5420 will always just be your current location. Thanks for sharing that, Jacob. Except it probably isn't going to let you share a link. I don't think YouTube allows that. So 5420 is X, 5421 is Y. Okay, that was easy. That should be our expected X and our expected Y, which I believe means this one is done. So while we have this knowledge fresh, let's go fix some of our other ones that I had wrong. The probe circular bore was one of them. Oh, wait, no, I was wrong. This shouldn't be 5420. This should be parameter 1, and this should be parameter 2, because the 5420 is going to change based on its current location, but the 1 and 2 won't. So if we go back here, this should just be parameter 1. This should be parameter 2. And let's see where else we can find this same mistake. So where is my files? I should have made a list of which of these I have modified already. I think it's just the circular one. So that was circular bore. So we probably need to fix circular boss. Oh, hey, look, okay. So number 1. And this one is number 2. Okay, so those 2 are fixed. This one is still working. Well, this one, did we finish this one, right? This is done. So I'm going to copy paste this logic because we should be able to reuse this. And now we can. So this is the 3-point, the boss 3-point. So bore 3-point would be the next logical one to do. And a lot of this math should be basically exactly the same. And I'll just go underneath the existing code, put that in. And let's see. That stuff never changes. Do they have X center? Yep. First vector location. Are they using the same words? Yep, they are. First, second, third. Y center should exist. This I calculate. Yeah, this I calculate. That I calculate up there. So the math should be good. I don't think there's anything that's going to change there. And we do have to change this. Again, I don't really understand what they're doing with the post here, but I know when you're going between a bore and a boss, you just switch these two. So I'm going to move that and do that. So clean up that minus sign. So this one should be good. Hold on, I'm going to blow my nose for. All right, so the 3-point bore should be done. That one was super, super easy because all of our logic and everything didn't change. Unless I'm making some sort of horrible mistake here. Nope, don't save the stream as a file. There you go, save this. Now, what was the other one that was left? There's boss 3-point and bore 3-point. Oh, I already did the circulars. Are we done with the logic? Let's check this. Yep, that one's there. Circular boss. Yep, that one's good. Okay. So I believe we have all of our macros done. I've done everything else here as far as I can remember. We do Y pocket. Yep, there's Y pocket. So I think we're good. Jacob, yes, I will publish these. When they're done, I haven't tested anything. I haven't done a single test, which is probably dangerous. Because for all I know, I've done every single one wrong, and I'll have to correct every single one. But I will publish these on my website at very least, and these are going to go back to Tormach. They'll probably pretty them up a little bit. Like the Tormach coders are really good. You know, they have all kinds of debug statements and test statements that I just don't do. They're probably better about variable names being consistent and stuff like that. So I will publish my version, but I'm going to give these versions to Tormach. Tormach will pretty them up, and then if they choose to, they'll publish them with the machines. Like they'll come out to everybody in an update is the hope. But if they choose not to do that, they don't have to. Then I'll have them available on my website, and I'm going to do a video on these, not just a live stream. But okay, so what else was on my to-do list? Add ability to probe without shifting the WCS. We did that. We did that. We did that. So we need to add the ability to probe without. Oh, we need to modify the post too. So what does the post need? It needs to reset the feature number at start of program. It needs a checkbox to turn on printing measurements. I think that's it. I think that's it. My phone's going off. Oh, it's all Discord. And yeah, Jacob, I know I owe you some messages and stuff. I've been busy and I haven't gotten around to that. All right, so let's see if we can turn on the ability to. Here, we'll start with a simple one, Xedge. Let's see if we can add the ability to store the current position and then recall it at the end in case you don't want to shift your work coordinate system. Oh, another one of my goals for this, by the way, is like in Fusion, right now to do the inspection and like probe geometry thingy, it's a manufacturing extension feature. I'm going to do my best to bypass all of this stuff wherever possible. Like you may have to do a pass through NC, but like I don't want you to have to use the manufacturing extension to be able to do in-process inspection. So I'm going to, in the macros, I'm going to write some ways where you can avoid that. But okay, so the X position will just reset the the X probing macro will just change the X position. So the first starting position equals 5420. Okay, and we already know that's the current X offset, right? Can we check that in PathPilot? Will they give us that information on their website? So where's parameters, numbered parameters reference? Yeah, okay. The current work coordinate system is 5221 through 5230. Okay, maybe we should just save those instead of worrying about anything else. So 5221, does that match up with what they're doing? Where'd my... They're using 5420. Is 5420 in here? Okay, 5420. Current position, including offsets. Okay. So that is what we thought. So I'm going to come up here and just save the XYZ for the current work coordinate. Oh, wait. No, except this would be the current. This would always be G54. We don't always want G54. Now the problem is, can we directly set this, or do we need to do a what do they use? It's like the something L20. We probably do need to use the G10. Okay, so let's start by grabbing. Okay, so the underscore at the beginning here means it's a global variable. We don't want this to be a global variable, so no underscore. So I can call this starting X equals, and that would actually be the same as that one, 5420. And then I can do starting Y, and that would be 5421. Starting Z. We don't actually need all three of them, but I'm going to do it so it's more copy pastable between others. The other programs, 5422. XYZ. Okay. And then we can come down here to the bottom. Okay, so there's that one. Let's do another. So we'll do subroutine 901, I suppose. What's the format? So I'm just going to copy paste this. If change WCS equals 0. Actually, can I do... Should I do not equals to 1, or should I do that to 0? Let's see. If this isn't set at all, I want it to change the WCS. So if change WCS is not equal to 1. So if it's set to 0, wait, maybe I should make this don't change WCS. If don't change WCS is equal to 1, It's probably bad formatting. What is it? Is this all supposed to be lowercase? I don't remember. I don't remember what the proper formatting is. Okay. If don't change WCS is equal to 1, then let me put in my end statement here. It's end if. Then I want these. Except I want these backwards. So I want... Oh, except we need to use the... I can't just set that variable. That would be nice. I need to use this. So I'm just going to leave that up there for reference. I assume I can do X, Y, and Z on the same one. So this would be starting X. Starting X. Starting Y. And, oops. Starting Z. I'm going to put in spaces for readability, though I don't think you need spaces there. So G10, L20, P. So P is the, in this case, the offset that's being changed. So it's changing it to 5220. So like it's changing work coordinate system, whatever is stored in here. So this could be like G54, G55, or whatever. That's being determined by this. And 5220, I believe, is the active work coordinate system. 5220 current work coordinate system. Okay, which I believe is what we want still. And then it's changing X, Y, and Z back to the starting values. So if this parameter, which we'll probably have to set through a manual pass-through, if that is set to 1, then it's going to revert. I need to get rid of that. It's going to revert everything back to the starting value. So I should change my note here. So if don't change, set back to starting value. And Norman can go fix my coding conventions late on his own. But I think that should be all we need, right? Let me see if I can find the reference for G10, because I'm not super familiar with it. G10 L20. So, okay. So P, yeah, X, Y, Z. An axis other than X or Z? What about Y? That's got to be a typo, because there's no way you can't offset Y with a G10 L20. So that's got to work. Okay, and we're not doing the A axis at all. Nothing in, well, I guess there, I don't think Tormach has any macros except for the ones that are on the controller that use the A axis. Like none of them that you can post from Fusion use the A axis. So I don't think we need to worry about that. We just need X, Y, and Z. The P should already be set. So I think that's it. I think that's all we need. So now we just need to go fix all of these. And actually, what I'm going to do to mark which ones I have changed. So right now, these are the name of the current macros. I'm going to rename them inspection so that I don't want to copy over. I don't want to erase the Tormach macros that are already on my controller. And so I'm just going to rename them inspection when I'm done editing. That'll keep track of which ones I've already fixed. And it will mean that I don't save over the existing Tormach macro. So just for safety. And yes, I know my green screen is really funky right now. Never mind. I'm not going to fix it. It's fine. It's fine. So the X edge is done. We can close that one. Oh, I should have saved that or kept that open for copy and pasting. Open back up, please. Okay. Let's start with this one, I guess. So we'll go copy our code up here. We should just need to copy paste this up at the beginning. Wait. Do we want to... So this is relative. This is its current. Let's go look back at that. So L20 is similar to L2, except that instead of setting the offset entry to the given value, it is calculated that makes the current coordinates become the given value. So if the tool is in a different place at the end than from the beginning, it'll be different. So I don't think we want to use L20. All right, we need to go open back up that one that we already did, this one here, because this isn't right. Shoot. I don't know if I can do this much critical thinking while talking. Okay, so what? Yeah, because we want to change. We don't want to change anything relatively. We want to change the actual XYZ position. So let's go back to our reference here. I should probably leave this open on a different page. Where are our parameters reference? That's not what we wanted. Numbered parameters reference. Okay, so we want these values, but we want to be able to get those dynamically based on whatever offset is active. Yeah, we don't want the current position. We just want this offset. So how do we just get this offset? Is there like a current offset? I mean, this is wrong too, because there's extended offsets now. Current position. Can we use the current position to get the offset somehow? If we could subtract the tool offset. Current position including offsets. Wow, this became way more difficult than I thought it would be. Let's go look back at the macros and see if we can learn anything. So how would we get the offset values? So they're pulling the first starting position. They do the boop. That's the probing result there. Or maybe not. That might be the probe tip diameter, actually. What is 522? Oh, wait, no, we know that. That's the work coordinate system. They're setting that to actual X. Oh, this was one of the statements that I modified actually a little bit. They used to have this math take place inside this statement. If anybody has any ideas, I'm open, because I'm a little bit stumped right now. Do they ever reference the work coordinate system anywhere? Not directly. They just have the first position to probe and the first starting position. Let me go look at a more complicated one. Yeah, 3-point boss. That's more complicated. So up here, they are basically doing the 1, 2, 3 thing. By the way, I have no idea what these @ signs and caret symbols mean. I asked on Discord And I don't think anybody else knew. Here, I can do that off screen. I don't want to do that on screen. Let's see if anybody on Discord knows that answer. And yes, I am stalling for time. Why I think. Did anybody answer? Oh, it's polar coordinates. Okay. Norman came through. Interesting. So that they're doing this based on polar coordinates. Huh. Who knew? There's the polar coordinates. Oh, so instead of XY, you do @caret. Wow. Okay, well, that's something new to me. I have many Discord messages. I'm sorry, everybody, I'm ignoring. Okay, so yeah, it's going back to the start position. I mean, we could do a G0 and just go back to the start position and then reset, but that seems dangerous. I might have to sit down and think about how we do this one. And by sit down and think, I mean bug Norman. Norman, are you here? This is what I get for streaming in the middle of the day. Well, if anyone has any ideas on how to do this, I would appreciate it. But I've just about used my hour and I am kind of stumped. Because I can set the current relative position, but how do I grab the actual offset and how do I make that dynamic? I don't know. There's, I'm sure, some named parameter to get them, but I don't think that named parameter is published anywhere. Where's the Tormach documentation? Ooh, we could check the Linux documentation too. All right, let's go back to there. So that's the result of probing. Some wild sounds going on outside. G92 offsets. Current chord system number. So that's the current coordinate systems, which again, if we were just always using G54, this would be really easy. Yeah, there's just not enough there. All right, let's check the path pilot. Coordinate system. Yeah, there's a whole bunch of parameters here. Again, that's how you get your X, Y, Z. Ooh, absolute X, absolute Y, absolute Z. Return current absolute X, Y, and Z relative to G53. That, I believe, is what we need. So hopefully they haven't changed this in Path Pilot, but I don't see why they would have. So let's go back to our macros here. Which one was I working on? That one. So I've already forgotten what it was called. There we go. Just copy paste it. Abs X. Oh, except I'm on the wrong side. So that needs to go over here. Abs X. I'm going to break some probe tips when I try these out, aren't I? So abs X, abs Y, abs Z. Okay. And this up here is the only thing that needs to change. Now, nope, wait, maybe I said that. So should this be L2 instead of L20 then? So let's pull back up our documentation here. Set coordinates. That's our L20. Where's our L2? G10 L2. So to define the origin of a work coordinate system, program G10L2, P whatever, where P is the work coordinate system. It doesn't change the current coordinate system to the one specified by P. Okay, that's fine. It can be inactive or not. If it's currently active, it takes the origin of the work coordinate system. So not relative, the actual origin. So I think if we come down here and we change that to an L2, XYZ starting location, P5, 5220. I think we're good. Are we good, guys? I have a feeling that everybody stopped following this a long time ago. But we should be good. All right, so now we can take this little snippet and actually I'm going to just come over here to the to-do list. I'm going to dump that there. And I'm going to come up here and grab this word soup. Just pay for Copilot. I don't know if Copilot does Gcode. All right, I'm going to dump that down there. Our indentation's all wrong, but I think that's fine. Yeah, I don't know if anyone's actually going to watch the stream when it's done. I understand that right now I'm just background noise for most of you guys. All right, so this one's done. I'm going to close that one, and I guess we'll do our probe 3-point here. So we need to copy this, and we'll put it right up here. Okay, and then we come down to the bottom. And right after our other thing, we copy this and put that down there. And hopefully, this should mean that we have it set up so where you can do measurement without changing the work coordinate system. I'm hoping that works. I'll have to do tests. This is why I'm not publishing these yet, because this will almost certainly crash your machine and break your probe. But I'll test it and figure it out. Well, I gave myself an hour. We're at about 56 minutes, 57 minutes. And at this point, I am just copy pasting code, which I mean, may be about as exciting as the rest of the stream. But I'm going to run it, but I'm not ready to run it yet. We'll do that as a different stream. Maybe tomorrow. I can probably designate an hour of tomorrow as Automation Week Day 2. But I think for now, I'm going to end it. And you guys get a cliffhanger so that you have to come back next time. We'll call it retention tactics and not laziness. But I do have to actually do some real work instead of just playing around with automation stuff. So thank you, guys. I will see you next time. And yes, I will send you a DM eventually. I'm sorry I haven't done that already. Bye.